Hello everyone, my name is Vince. I'm co-founder of zk.Link. I'm happy to be here to talk about the solution that we're building and our mission to unite the Ethereum ecosystems with a roll-up-centric multi-chain future. So what we're building is a secure, efficient, and unified trading execution layer that can aggregate liquidity across multiple rollups and blockchains and secured with zk snarks. The problem we're trying to solve three major problems. First, the problem is liquidity fragmentation with the emerging layer 2 ecosystems, including OP rollups and zk rollups. It is pretty evident that we are going to see liquidity silos and fragmentation formed on these different rollups. So we need solutions to unify liquidities for these rollups to be able to talk to each other and for liquidity to be easier for the users to manage their assets and move liquidity from one to another. Either we can do this through a bridge, or either we can do this through some infrastructures like zk.Link that can facilitate this process while not introducing additional security risks that we often see on cross-chain, cross-rollup bridges. And also, by doing this, we're also simplifying the multi-chain user experience, simplifying the cross-rollup user experience. These are some of the features of the zk.Link protocol. First of all, we want to provide an easy to deploy infrastructure for application builders. We're directly building this as an infrastructure provider where we want our builders to, we want to save the development cost and save the hard work. We do the hard part for them. So we build the use cases with low-level machine language, write the zero-knowledge circuits for them. So they just need to use the high-level APIs that we provide, just a few lines of code for them to minimize the development cost and development work that they need, especially on the blockchain part, so they can just focus on building the application itself, focus on the financial products, features. Currently we can support a few types of applications, including central limit order books, AMMs, RWA derivatives, NFT issuance and trading, with built-in account abstraction to facilitate the user experience to enable mass adoption that we have often been discussing about. And we also want to enable, with this within our execution layer, we also enable instant settlement execution and faster finality. We can settle the transaction directly on chain, so it's a faster finality compared with the opportunity rollups. As we're doing this through a classic zk rollup structure. This is the protocol architecture. On this slide, you can see that there are different types of applications. There are a few different applications, 1, 2, 3, 4. Application 1 and application 2, they are sharing the same setup. The network collections on this is just an example. There is Ethereum, BNB chain, and Starknet. It's a combination of Ethereum outer layer 1 and Ethereum layer 2, zk rollup layer 2. These application 1 and application 2 are committing the transactions, batch the transactions on chain to the contract and verify contract. Application 3 and application 4 are committing the transactions to another setup, which is not necessarily the same compared with the first setup. It could be a network collection, different network collection, including outer layer 1s, zk EVMs, zk VMs, optimistic rollups, etc. as long as it satisfies the needs. So it depends on the specific needs of the application themselves. And what is important to notice here is that the setup 1 and the setup 2, they can actually share the cost of zero-knowledge proof generation and verification through a recursive zk process, through a recursive zero-knowledge proving process. This is a type of networks that are supported by the protocol. As I just mentioned, the four types of networks that we currently support includes most of the networks that are popular right now. Outer layer ones, including Ethereum and the outer EVM counterpart layer ones. Actually, we're also doing this on out layer ones, which is even incompatible like Solana. We have open sourced the first zk verified contract on Solana a year ago. And zk EVMs, the ones that we're familiar with, zk.Sync, Scroll, Linea, Polygon zk EVM, Tycho, etc., and optimistic rollups, including Arbitrum, Optimism, Base, Mantle, many ones that just launched based on the OP stack. And EVM incompatible zk VMs like Starknet, we're also doing integration on that, and just went live on the testnet. Will be live this month on mainnet. Here is an example of how developers can choose their deployment of network collections. So this is one level of customization that were provided to the application builders. So they can choose a combination of different networks, types of networks that we support. So one application may say, okay, I need Ethereum, I need outer layer ones. For business reasons, they can choose to deploy on BNB chain, since there's a lot of obviously liquidities as it's backed by Binance, and also some applications say, okay, they want also the liquidity from Polygon, from Avalanche, etc. And also they are seeing the potential of zk of the Ethereum layer 2s, especially currently we see there's a lot of liquidities going from outer layer ones to the OP rollups. So they could choose to also include Arbitrum, Optimism in this public network collection. And some of the application may say, okay, we want to strictly share the security, derive the security from the Ethereum. So we just want to deploy on Ethereum mainnet and Ethereum zk rollups, as the zk rollups are theoretically inherit the security characteristic of Ethereum itself. So they can just choose to deploy on zk VMs and zk EVMs and Ethereum mainnet. This is just an example of the application setup. This is one of the earliest applications that is building using the zk.Link middleware infra. This example, they have deployed on Ethereum, BNB chain, Starknet, and a few other outer layer ones and layer 2s, which are already represented by BNB chain and Starknet. So on this graphic, you can see that the zk.Link option service provides the sequencing service to batch the transactions, which you generate a block and then run the proof, generate a proof, and then validator system just post the proof together with the roots, state roots, to different chains, base chains that they connect to. And the rollup contract will verify the proof. And then at the same time, the final roots sent to each of the contract are not necessarily synchronized. Then because BNB chain cannot directly talk to Ethereum, so these two contracts, they do not know whether they're receiving the same information state root. So how to synchronize the states? It can be done through external Light Oracle service, which is a generic messaging service that helps to pass the final roots from different chains among each other, and the contract will compare to judge whether they're receiving the same information. So this is separation of the two steps is to mitigate, ensure that the option service is not able to cheat the verified contract by sending false deposit information to rack some liquidity from one chain. As long as, so the security assumption here is that as long as the Light Oracle the service is decentralized and independent, they do not conspire with the validator service, which are totally two independent group of node service, then there's absolutely no chance of conspiracy. And what is important to note is that the Light Oracle network service can also include stakeholders in the system. For example, for one application, one heavy application, let's take the example of DYDX. So some market makers may just choose to run the general messaging service themselves. So they do not need to trust anyone. They do not need to trust Layer 0, Chainlink, or any other service providers. They just need to run a very simple program to check the consistency of the final roots received on different chains, because you can easily get that information from the blockchain scan, blockchain explorer. This is a very light service, and this will mitigate the risk when you have deployed to multiple layer 1 chains. This is how you communicate and ensure the consistency of the final roots and settle the transactions on each of these chains. and also, this is down to a classic zk-rollup structure, so there's also the problem of data availability. This is to ensure that no matter what happens, your funds on zk-Link platform is safe, and you can recover that no matter what happens with the DA. So there are different levels of DA. This is also customizable, right? So applications can choose to deploy the DA on Ethereum, which is obviously the most secure and also mostly expensive. And also they can use external DA solutions that we have, like been saying recently, like EigenDA, like Celestia modular solutions. This is and also under some extreme cases, for example, for some applications like gaming projects, you don't necessarily need to deploy DA on chain. They can have their own committee, a data committee. This is, I think there's some projects already doing this, and you can have a mixed model of both. Well, it depends. This is business decisions over technical constraints. So it's for different types of use case, they can have different choice. There are some roles in the zk-Link system. So this is similar to other zk-rollups. So I'm going to it's the same. You have validator, you have sequencer, you have prover, and you have the app developer, and you have users, and also core contributors to coordinate all this. For developer integrations, right now we're supporting trading use cases, including sports, derivative, OFT, omni fungible token. Apparently, this is natural because we are building on top of multiple rollups and chains. So you can issue a token which is native OFT, and also very soon we'll be able, in Q4 this year, we'll have NFT issuance trading, RWA derivatives to cover more use cases. We have very detailed documentation on our website for developers to learn about how to use the high-level APIs. So this is some of the important steps and milestones we achieved for the past few months. We have performed the first Dunkirk asset recovery test. This is a very important concept for zk-rollup setting, because people always talk about why rollups are safe, because they can use the DA to restore the layer 2 status, so no matter what happens, and users will be permissionlessly able to exit their funds to recover their funds. I think, to my knowledge, zk-Link is the first team to perform this asset recovery test in real use case. In May this year, we have performed this, and over a 3 days period, we have helped over 60,000 users, generated over 120,000 zero-knowledge proofs, and recovered the funds from 7 different testnets. Well, of course, it's testnet assets, so it's not real assets, but still this is a very good proof of concept that you can always be assured that you will be able to recover your funds whatever happens to the option service. We also have conducted a third-party security audit several rounds already, and we launched the alpha mainnet on 10 mainnets, the Ethereum outer layer 1s, Ethereum layer 2s. This is a case study. So this is the first application that is live using zk-Link solution. It is a decentralized order book exchange that offers bridgeless multi-chain crypto trading features, including sports and derivatives, with unified account and cross-margin, portfolio margin enabled. This is pretty much like a centralized platform level of user experience. So what is important, I think, for this application is that they actually offer the similar user experience to centralized platforms, because you can trade at a one-stop tokens, assets from different ecosystems. There are 10 minutes right now integrated, so you don't have to move your funds among these 10 different networks, 10 different mainnets. You can just deposit whatever tokens you have from these 10 supported networks to this platform, and buy whatever funds or tokens are available listed on this platform. And also, you can merge the token liquidities. For example, when you deposit from Arbitrum, from Ethereum, from BNB chain USDT, they will be automatically merged to the same USDT. So you have these liquidities combined. And also you will be able to use the collaterals, the different gas tokens, and there will be like hundreds of tokens supported that you can use to use as collaterals to trade derivatives. This will greatly improve the capital efficiency and unlock new trading opportunities for on-chain users. So ultimately, we want to provide an infrastructure solution for application builders that can deliver a truly seamless multi-chain experience with a scalable and a secure applications. So this is going forward in the very near future, zkLink will shift the focus from the current layer 2.5 hybrid model to layer 3. Why we're doing this? Because as we seen the quick development recently on the layer 2s, we believe, we are very confident, and our thesis is that the near future we will see a lot of applications building and users migrating from the existing outer layer 1s to layer 2s. So this will make it possible to settle transactions directly on layer 2s, and then the layer 2s settle the transaction to Ethereum. This will further improve the efficiency, optimize the efficiency, and reduce the cost of the settlements of the transactions. This will unlock, I think, according to our internal stats, we'll be able to bring down the cost per transaction from 0.01 to 0.001. So it's an improvement by order of magnitude. And this will truly, for the first time, to unlock possibilities for on-chain traders, users to support high-frequency trading and different strategies on trading for applications like central limit order books. This is very important because currently there are constraints on their cost, and this will make it competitive compared with the other solutions like Cosmos, trading specific application specific layer 1 chains like Injective, like C. They used to have great advantage on the cost per trade, but right now, if we're doing this through layer 3 and set transactions on layer 2s, of course, I think this is, we're doing this mostly, this is still customizable, right? Some applications can still choose to deploy on zk EVMs, zk VMs plus the OP rollups. But to strictly inherit the security share, derive the security from Ethereum, we do this through zk EVMs and zk VMs. This is an example on this graphic. We do, for example, through Starknet, Linear, and zk.Sync, and they will indirectly they will post the transaction to Ethereum through the official bridge, the contract, and set final to achieve final finality. So this will make zkLink the first multi-rollup layer 3 trading execution environment, which will be a lot cheaper than what it is today, and unlock the potential to enable mass adoption on decentralized trading platforms. In conclusion, what we're trying to achieve is to enhance the layer 2 ecosystems by unifying liquidity, by simplifying user experience across rollups especially. We believe the future of crypto trading will be rollup centric and also will be multi-chain. So users will need infrastructures and applications that abstract and simplify the complexities of different rollups, multi-chain ecosystem. They need in the solutions that they can trade at one stop, whatever trading opportunities they are interested in. And this will enable and unlock the possibility of a decentralized Binance or a decentralized FTX. This is an ongoing summer tour to allow our users to explore at one stop the different layer 2 ecosystems. Though you have different quests that you will be able to deposit and withdraw and use applications on top of different layer 2s. This is quite interesting. If you don't know yet, you can take a look. Thank you very much.